Right, I'm going to make this into a series where I'm going to do a bunch of tutorials for the PIC18 F45K20 in assembly. So let's get to work. Firstly, I'm going to start my IDE. You should have already downloaded and installed it. I'm really not going to do a tutorial on that, that's way too easy. So there I'm starting my MPLAB. Oh, I run Linux. So this is how I started. I suggest you run your MPLAB as an administrator if you're using Windows. Otherwise you may have problems with the USB when you want to program the PIC. Right, now you can click on this yellow box right there, or under File, New Project. It's exactly the same thing. So there we go. So under Microchip Embedded, you're going to pick Standalone Project. Now to do this quicker, you can go to the section which is Advanced 8-bit MCUs, and then it lists only those microcontrollers here. So PIC18 F45K20 is right there. Right, so you select your micro, you click Next. Here I already have my PIC3 plugged in. If you're fortunate enough to have a PIC4 already, you pick that, but I use a PIC3, so I'm going to pick that. Next. Right, so under compilers, if you have already installed an XC8, you can program the PIC in C, but for everyone watching this video will probably be doing it with assembly for obvious reasons. So you click on MPASM. This comes pre-installed with the MPLAB X IDE, so it's already there. Then you just Next. Project name, I'm going to call this tutorial 1. Right, and I'm going to say set as main project and then finish. Right, so first of all, you will see that you have all of these folders that are created for you. So under source files, you're going to right click, then new and other. Then here you will go under assembler, and then you will click assembly file.asm. The .asm stands for assembly, and you click next. Then you give it a name. I always name mine main. Oh wait, that exists already. Main. Oh my. I made this beforehand, so I'm just gonna call it temp. But for all reasons, you can just name it main next time. Right, so finish. So you're going to have this empty file that we're going to turn into a skeleton that we can just copy and paste, like I've already done in the other files. So first of all, you have title. So title is just something that makes it nice for you. First assembly tutorial, right? So you have your title, then list P equals PIC18 F45K20, and then probably the most important is include P18, note it's P, not PIC, PIC18 F45K20.inc. So with these three lines in place, you can start with the coding. So there is a bunch of assembly directives, and these directives you'll find in the data sheet, which we will look at in the next videos for setting up our setup bits. But something that every assembly program has, well, most, except if you're doing really weird stuff, is you have an org. Org is an assembly directive that points the current execution address to a certain value. So you make it 0h, which is the beginning of all the memory in the programmable memory area of the PIC. So org 0h starts here. This is where the address starts for execution. So underneath that you say go to, and I always have a setup section. Right, so what I do now is I have setup. Then all my setup bits are here, setting up stuff, and then right under that I have start, and then I have this go to start loop, and then I have an end. So let's look at this real quick. You have the org that sets the current programming execution address as this line, which starts here. So this go to setup. Basically, this changes the current pointer of execution to wherever setup is. So setup gets converted to an address, which is this address right here. When the assembly is being compiled, this gets turned into a binary address. So as soon as it starts up here, it will go directly to this line right here. So here we're going to do the next videos setting up stuff, and then in start you actually execute code, real assembly instructions. And let's just write something here just so we have something. We're going to do a very long part on what this is and the wreg and everything. Right, so as soon as this finishes, it goes to start, which is a new address. Then it executes all the code in here, whatever it may be, and when it reaches this directive, it says go to, which is just like this, but instead of going back to setup, it goes to start. So this turns into a loop. So setup gets executed only once, and after it's executed, it goes to start, and start continuously executes. And then finally, at the bottom, you have the end. Right. So this is just the first part of the video. The second part is we want this to be able to work on our pick. Let me just see if this compiles. All right, there's a problem. Found label after column 1. Let's see, does that fix the problem? Oh my, it's a spelling mistake. Oh boy. There we go. This should be fine now. Right, there it compiles. Sorry for my spelling. You will see in the next videos sometimes I mistype something. Right. So for it to work on your pick, you need to set up a few things. So you will go to target memory views and click on configuration bits. Now I'm going to show you how it's supposed to be done and how you should do it in a test. But I will also show you how you should do it for keeping the code nice and clean. So here is this really massively long list of configuration bits. All right, so what you're going to do, FOSC, which is the F oscillator, this needs to be set to int IO67. Right, so you click on that and it says, right there, it changed. That is the first of 3 that needs to be changed. The watchdog timer should also be switched off, as well as LVP. So after you change those 3, you can click on generate source code to output, and boom, all of this is generated out of that. So you can look at that. Usually you just click here, Control A and the Control C, and then all you do is you go above org and you paste it. Right, let me just compile and build files. Oh yeah. So you should just watch out. As soon as you have this generate, you will see this line is repeated. That line right there. So you need to just take that out and everything should be fine. There it compiles nicely. So this is the right way of doing it. When you're in a test and you need to set up the bits, this might be marked, all of it, not sure. How I would do it normally is I would just not do that at all. Let's just bring that back. Okay, so how I like doing it is I say config and then like these files. I just say config, F oscillator is int IO67, W10 is off, and LVP equals off. So here I'm going to say fosc equals int IO67, and this is all valid because it's just code. This that's generated for you, it's just code, that's all it is. So I can write config WD10 equals off, and as far as I know LVP was off as well. There we go. So I can write here config LVP is also off, and if I compile it or build it, it works exactly the same and build successful. Right, so this is for setting up your template, and as you can see here, I've already done the second tutorial, which I'm going to upload and tell you about about later. So you can see I just copied and pasted the template, and I just changed a few things here and there, and it's exactly the same thing. I wanted to set it up so it's nicely. So from this point onwards, this is just a template. But just so you know how this works, you have your title. You can leave it out, doesn't matter. Preferably to keep the list in. Include must be there because it contains all the directives like org and goto and movlw, all the nice and beautiful little things that assembly is going to use to ruin your life. That is all contained in that file, so you need to include that. Also the config bits, you can set it up like this. These are the only 3 that matter. These are all of them. You don't need all of them because, as I said, this is the only 3 that matters. But when you're in a test, just copy and paste this, and just don't go to that section of the code ever again while you're busy with it, because it's a mess. Right, see you in the next video.